Hello everyone. So we'll start with Spring Boot today, and let's first understand why we need Spring Boot and what is the advantage of using Spring Boot. We'll go about a bit of theoretical class today because we need to understand why we need Spring and Spring Framework or Spring Boot and how does it make our life easier. So when you want to develop some application in a real world or in some company, so you get certain requirements, and those requirements are brought to you by the business, and you basically go over and groom over those stories, and then you try to design some document how you will go about developing that particular application. So after that, what you do is you start breaking down different tasks, and then you start your development. Sometimes you might need certain review of that document as well, where you want to get some guidelines from your senior folks or your peers, such that you can begin the development. So when you get the requirement, you basically, if you are a backend developer or a front end developer, like backend developer will be mostly developing the APIs, and front end developer might be developing the UI interface that you see on the browser. So as a backend developer, your primary role will be to develop the application on the backend side, means the entire logic piece, or uh, how you communicate with the data layer, what you need to send to the front end. Those kind of things you will have to be aware of, and how you basically do that, what kind of APIs you will develop such that your task is achieved. So all those things you need to first decide, go on to go on to start your development. So there are different API contracts. So when I say API, means API is like application programming interface. So those are kind of like different types of requests that you will need to create in order to achieve your uh, in order to complete your requirement. So Spring Boot basically helps you to ease your uh, development process. So it will help you to develop your APIs very easily. There were a lot of frameworks even before Spring Boot. So if I talk about like Spring MVC, there were like Spring AOP. So Spring MVC was also very much popular. Spring MVC. So by Spring MVC, I mean that MVC stands for basically Model View Controller. So what happened was there was this when I talk about this Spring MVC, it is like Model View Controller, and it is also a architectural design pattern, and which helps you to develop a lot of applications. And Spring MVC was also very popular, and it worked for a number of years before Spring Boot came into picture. So Spring MVC is basically model view controller, where your uh, model is basically the data that you drive between the view and controller. And view is, V stands for view, and view is basically what you see on the browser. It is basically the UI, and controller is basically like driving your model, that is the data to the view. So controller will be the front receiver of your request. So controller gets the request first, then it processes the data, drives the data, and it sends it to the view. So view is actually your front end or the UI that you see. So this architectural design was also very famous, and it worked for a lot of years. But there were some redundant things that we used to do while we were creating projects with Spring MVC. And we will see what were the pain points that Spring Boot helps us to uh, Spring Boot makes those pain points very easy, and it helps to develop our application very easily. So let's go about an introduction to Spring Boot. So Spring Boot is a module of Spring Framework used to create microservices. Now, many of you might be aware what are microservices, and many of you might not be aware of what a microservice is. So let's say like 15-20 years back, there was a concept that when you start developing an application, you develop all the modules in one place. And what happened when you develop all the modules in one place, you deploy the application also all together. So suppose even if there is a small business requirement change, suppose your application is already ready, you have a pre-existing application and you got some requirement from the business to make slight change in the application. So at that time when you make that change and test out your change and try to deploy your application onto some cloud or onto some VMs, so you have to basically deploy your entire application. Even if there is like minimal code change or minimal changes in your application, you have to basically deploy the entire application. So one thing is that takes a lot of build effort. Means what is the need of deploying the entire application if I have a very small change? So microservices come when microservices came into picture, it was the concept, it was like another architectural design where we divide the application into like very small services, very small services, and all those small services are basically like uh, all those small services can communicate with one another, and they can pass data to one another, and they all can be deployed independently. Those microservices can exist independently as well, and those microservices can be deployed independently, they can be worked upon independently. So microservices are basically uh, services are uh, which when combined help you to develop your help you to reach your business requirement. So microservices are basically uh, kind of like dividing your old monolith architecture. By monolith architecture, I mean that it was the old concept where the entire application contained all the business logic. Now, when we develop a microservice, we basically divide that monolith application into like small modules, and those modules will help us to build the application. Now, what advantage we get with microservices is, see, let's say we have like 5 modules, and each module can exist independently. And if there are like new developers in the team, now they don't have to like understand the entire code base, like all the 5 microservices to start their development. Even if they understand like one of the modules, they can like get started with the development. So that is one advantage of microservice. And let's say you have some small business requirement change in your application. So you will just identify which microservice contains that particular piece of code where I need to make the change. And once you do that, you make the change in that particular microservice. So you just need to deploy that particular microservice to the cloud or some other place where you are using your deployment process. So this eases out this like helps you to like deploy your application quite easily. You don't have to like deploy the other applications which where you have not made any change. So this like reduces the build effort. This reduces the application build effort and deployment effort. So that is like one of the major advantages of microservices. And microservices have like some other benefits as well. Like there you can have different microservice design patterns. Like one module can have a independent database, then uh, each module can like independently exist. Your you can like create some modules which can be like reusable, which can be like called by another microservices. Means let's say we have some common microservice, and that microservice, that particular module holds some common code which is being used by a lot of different modules. So you can like create some common module, and then that common module can be used by a lot of different modules. So these are some of the advantages of microservices. It helps you to divide your modules, and each module can independently coexist, and you can have like communication between your microservices. So these are some of the advantages of using a microservice pattern. So you might sometimes be asked this interview question as well, like why we started with microservices, what was the need of that, and why we gave away the concept of monolith architecture or monolith way of like designing the applications. So you can like provide these points like what I just said. So let's go ahead. So Spring Boot is a module of Spring Framework used to create microservices. It allows us to build a standalone application with minimal configurations. So Spring Boot allows us to build a standalone application. Standalone application means an application which can be like which can exist independently and with minimal configurations. Means the configuration part that you have to do is like very minimal, or like it has like zero configurations. Means when you like create your Spring Boot application, it automatically gives you some structure and some kind of like annotation based support that helps you to like run your Spring Boot application with minimal effort. In Spring MVC or in earlier Spring frameworks, we had to do a lot of configurations, and those configurations like took a lot of effort from the developers, and that's why those were not very means those were popular at that time. But once Spring Boot came into picture, so Spring Boot like helped us to develop applications with very little configurations, like with very minimal configurations. And when you like don't have to do a lot of configurations, you can like focus more on the business logic or the requirement that you want to work on. And that is the advantage of Spring Boot. That's why like Spring Boot, when it came to the picture, it became popular like very fast. And each of the companies, each of the individuals started to adopt like Spring Boot, and that is why Spring Boot is one of the very hot topics for a backend developer who is like working on Java, or who is like developing some backend application with Java. So Spring Boot is their ultimate choice. They have to basically learn Spring Boot. If you see today in the market that you are a Java developer, the next ask would be, do you are you aware of Spring Boot? Have you developed application with Spring Boot? So that is like very demanding. Spring Boot is very demanding these days. So Spring Boot helps us to build a standalone application with minimal configurations. So it is better to use if you want to develop a simple Spring based application or REST services. So we'll go over what basically REST services are. I'll because ultimately we'll be developing REST web services to achieve our goal. So REST web services are basically used to, that's also like one of the architectural design patterns that will help you to develop APIs. So we'll go over and see what REST web services are. So first let's see some of the introduction for Spring Boot. So why Spring Boot over Spring? So when I talk about Spring, I mean that Spring basically means like Spring MVC or earlier Spring frameworks. So why we basically have adopted Spring Boot over the earlier pre-existing Spring frameworks? What was the need of that? Means we were already able to develop applications, but why we started developing applications with Spring Boot? Why it became so popular? Let's see some of the points. So Spring Boot basically reduces boilerplate code. So Spring Boot helps you to reduce a lot of the redundant code that we used to write in Spring Framework or in Spring MVC. So there were a lot of configurations or a lot of redundant code that we used to write in the earlier Spring frameworks. Now, with the help of Spring Boot, it reduces those boilerplate code, and we can just create some simple aspects and reuse those things as well. So Spring Boot has got some way of coding that will reduce the boilerplate code, and we don't have to like write some redundant code or the code which is not really required. Even at the back, means what happens, this Spring Boot also works on top of Spring MVC. Means Spring Boot is basically an enhanced version of Spring MVC and with minimal configurations. So there is like minimal configuration or auto configuration feature supported in Spring Boot, that all the configuration related stuff you don't have to worry about that. So that reduces a lot of boilerplate code. So that's why Spring Boot makes our life easier. So let's see the second point. So no need to configure XML file. So when we used Spring Framework or Spring MVC framework, there were a lot of configurations which was done in an XML file. So when we do a lot of configurations in XML file, generally in a big application, you would see like a lot of beans which were configured in the XML. So beans, when I talk about beans, you might hear this terminology a lot in Spring. So beans are like simple Java Pojo classes which you will use for creating the request and responses. So like suppose while we were studying core Java, we were creating some objects, right? We were creating some classes like employee class or the student class. So those can be considered as the Pojo classes. We name it as like Pojo classes in Spring, and you can like consider those Pojo classes as beans. Means you will see those beans being used by different Spring modules. So no need to configure XML file. So earlier Spring frameworks basically used those particular beans in the XML file, and there were like a lot of configurations done in XML file. And maintaining a long XML file is very tedious. Means if there is some configuration which went wrong, it is like difficult to debug in an XML file what went wrong. So how you map your different layers, like how you are calling your data layer with the service layer, how your service layer is being called by the controller layer, all those mappings have to be done in the XML file. And what are the configurations you do for an application startup, how your application startup should behave, all those things were configured in the XML file. So it was like very tedious to maintain that XML file. So now with the introduction of this Spring Boot, basically it helps to remove that configuration of XML. So you don't have to do that configuration of XML. So at the backend, Spring Boot works in a way that it does that particular things for you. You don't have to care about that XML configurations. So there are like annotation based approach which Spring Boot will provide you. Means there are a lot of annotations that we will be using in Spring Boot, and those annotations when used, they like remove a lot of the redundant code, and that code is being already it is there at the backend. It works on those on top of those concepts, but you just have to place some kind of annotation. So even if like while studying core Java, you might have seen that to connect to a database, we wrote some code, we loaded the drivers and all those things we did. In Spring Boot, connecting to a database would be like easy. Means in your we have some property file where we can just like kind of map some kind of database configurations, and you will be able to connect to that. So there are like similar lot of things that you can do with Spring Boot. So you don't have to like worry about the configurations, and similarly you don't have to configure the XML file as well in Spring Boot. Let's see another point. It provides support of embedded server. So earlier, when we used to develop this Spring MVC or Spring framework based application, or even before Spring, there were some frameworks like Struts framework. So when you want to develop any application, you need some kind of like application server. So means you have written some code and you want to uh, run the entire application. So you will need some kind of like server, right? So that server will run on some particular port, and on that particular host and port, you will basically provide some URLs or APIs that you have developed. So that application server has to be there to start your application, and uh, basically whatever code you have written in your application will be run by that application server. So one such example is your Apache Tomcat server. So when we had like Spring Framework or Spring Boot framework, we earlier we needed to place that particular Tomcat server in your application. Means you needed extra effort to utilize that particular Apache Tomcat server into your application such that your application can be run. Now, when you start your development with Spring Boot, you don't have to manually like add any application server or Apache Tomcat server into your application. So Spring Boot basically provides you the facility of embedded server. Means that particular server is already there once you start creating your application. So you just need to like write your code, and that particular server will be available for you, and that can run the application for you. See, we already have discussed like the means minimizing the configuration part in the Spring Boot. So you don't have to like worry about the configurations. You don't have to worry about the embedded about including any application server in your application. So that is taken care by Spring Boot. See, just we have discussed like 3 points, and it has like already made life for a developer very easier. So we'll see like what are the additional benefits of using Spring Boot as well. But you don't have to worry about the configurations. You uh, your a lot of boilerplate code in the code base will be removed, and you don't have to worry about any application uh, uh, server that needs to be installed in order to run your application. So these are some of the benefits of Spring Boot. Let's see other benefit of Spring Boot. So it offers functionality of H2 server. So H2 server is basically an H2 database that can be embedded in your application. Now we have seen that in the previous class, while I was talking about the JDBC connectivity, I installed one MySQL client and we were able to connect to that particular database. Means that is the usual way. Even in when you develop application in the production environment, or when you write any application for any company, you would be using some kind of like database client, be it like MySQL client, or if it is like Oracle client, you will have to use that particular client. But Spring Boot does offer you functionality of an S2 server. S2 server is like base of like S2 database server, and that is like an embedded database. So that embedded database, it can be you don't have to basically like install a lot of things. That embedded database will be like easily available to you in your application. Suppose you want to do some kind of like proof of concept or POC or some uh, spike that you are doing. By spike, I mean that you are doing some kind of like uh, POC and you want to like test out whether this works or not. So, and you don't want to like install a lot of like database clients and all. So there is some kind of like H2 database server that is available. So with Spring Boot, you can easily embed this S2 database and you can start using it. And you can like write all the queries what you used to write in MySQL or Oracle. So this provides you that facility as well. Now let's see another point. So Spring Boot basically provides you auto configuration. So auto configuration means on top of Spring MVC, you have a lot of annotation based approach. So when I speak about annotation based approach, you would have something like at the rate autowired or at the rate bean. So this will help you to inject the dependencies, and this will help you to do auto configuration. One such example is when you write at the rate Spring Boot application. Means we will see these annotations one by one when we start developing the application. I'm just giving some example for now. Like there is one annotation like at the rate Spring Boot application. So that annotation will take care of like starting the application for you. Means that annotation is the starting point of your application. So we'll see how that annotation makes your life very easier. You don't have to like provide any commands or any XML configurations for starting your server. So you just need to provide at the rate Spring Boot application in one of the classes, that is your main class. We'll see how we write that code. But Spring Boot makes your auto configuration. With the help of auto configuration, it makes your life very easier. So next point, minimal code using annotations. So that's what I discussed now. There is like minimal code that needs to be written, and that code will be mainly your business logic. So business logic, whatever is there, that you have to write, but these annotations will make your life easier to, and it will like do a lot of the work which you have to do earlier, that will be taken care by the annotations, and we'll be using a lot of annotations. So let's see another point. There is dependency injection and inversion of control. So dependency injection and inversion of control, these are like uh, topics which might be asked in an interview. So uh, these topics like dependency injection and inversion of control, you might get in an interview question as well, and this is like important as well to understand what dependency injection is and what inversion of control is. So dependency injection is a way to basically inject the dependency of a framework component by the Spring framework. So let's say you have one class and that class requires some other component. Let's say you have some controller class and that controller class needs some component in that particular class. So how do you inject that dependency? Let's say we take the example of one of the let's say in real life we have an employee, and and that particular employee has an address. So let's say we have an address object created. We have created one address class separately, where that address class has some attributes like the street name and city name and the country name or the zip code and all those things. So that address class can independently exist, right? Now our employee class, let's take the example of employee class. Employee has an employee has some employee ID, employee has some name. So we have some different class like employee class where we need to provide the attributes or data members as uh, employee ID, employee name, and let's say employee designation, and let's say address. Now see the scenario. You have one employee class and you have one address class, and in the employee class you have data members like employee ID, name, and designation and address. So what you can do, you can inject that particular address class in your employee class, right? You can inject that particular address class and inject it into your employee class. So that kind of injection is called dependency injection. Means you already have some component created that was your address class, and you have injected that particular component into your employee component or the employee class. So this is a classic example of dependency injection. So your employee class can basically inject the dependency like the required dependency. So that is what we call dependency injection. Just a minute. Yeah. So this dependency injection that helps like one class to inject other components in that particular class, that makes our life very easier. And with the help of like Spring Boot, this has become even easier. We will see how dependency injection can be like achieved by different methods, and how we can like inject dependencies from one component to the other component. So those kind of things are those kind of things like make our life very easier. And there is like another important concept, that is like inversion of control. So inversion of control or IUC, you might hear this terminology a lot when you hear about Spring Boot. What is DI and IOC? So DI would be your dependency injection, IOC would be your inversion of control. So a lot of times people must people must ask you like what is IOC or what is DI. So you must understand DI is basically dependency injection, a way of injecting dependencies in another component. Means if a component requires some other components to be injected, or some classes or some objects to be injected in order to complete itself, then we have to use the concept of dependency injection. And IOC is one of the design principles, or inversion of control is a design principle that is available within the Spring framework. And this design principle basically helps creates the objects, configuring and assembling their dependencies, and managing their entire life cycle. So it is one of the design principles. Inversion of control is the design principle which helps in creating objects, configuring them, and managing or assembling their dependencies. And the way we practically do this is basically dependency injection. Means IOC, or the inversion of control design principle, is achieved practically by dependency injection. So this framework, Spring framework or the Spring Boot framework, will help a lot in creating these objects, in managing their entire life cycle. And this is all because of inversion of control design principle. So at the back end of things, means this dependency injection does this work for you. Means dependency injection is basically the practicality which achieves, which helps to achieve this inversion of control. We'll further see like how, what are the different ways of dependency injection, and what are the different ways we can like inject dependencies in one component. Let's see another slide. So what are the benefits or advantages of Spring Boot? So let's see the advantages. So fast and easy development of Spring based application. So with the help of Spring Boot, now that the configuration part is removed to a minimal effort, you can completely focus on your business logic and the requirement that you have got from the business. So this way your development process becomes quite fast, and with the help of different annotation based approach, you will be like uh, your a lot of code will be removed. When you start using the annotation based approach, that annotation will take care of a lot of boilerplate code that you don't have to write, and that is why your work becomes easier. You have to focus now mostly on your business logic that you want to implement. So the development becomes quite fast and easy for the Spring based applications. Even means one thing is the development becomes fast and it becomes easy as well. Just a second. Even if you are not aware about the Spring framework, so you don't have to worry about that. You can directly get started with Spring Boot, and with the annotation based approach, your life will be very easier. Now let's see another point. No need for the deployment of war files. So when I talk about like war files, jar files, these are ways of packaging your application. Suppose like you have created a module and you want to deploy that particular module. So earlier what we used to do is like you have some server where you want to deploy the application, and those were like legacy applications. Means I don't know if anyone of you has like worked on like very old legacy applications, but those legacy applications had the packaging style as war files. Now, in the modern era, we basically focus on packaging the application as a jar file. Earlier, we used to create war files, and those war files needed to be deployed, and you needed to take some manual efforts in order to like deploy those war files to some Apache Tomcat server. And creating those legacy applications was like quite a tedious job, and deploying these war files was another tough task. Means you had to like follow some steps to like deploy these war files. Now our application can be packaged as a jar file. Means we will see how in Maven, means when we develop a Spring Boot application, we will use some kind of Maven dependency management that we will see. And that Maven dependency management, we can basically mention the packaging style as jar file. So we don't now need to deploy war files. So that pain point has also gone away with the help of this Spring Boot or Spring Framework applications. Then Spring Boot also helps you to create standalone applications. Means you can create separate modules or separate microservices, and you can deploy those applications. And these applications will be able to talk to each other on its own. Means there are ways how they can communicate to each other. So the standalone applications can be created with the help of Spring Boot and fast development of application. So development of application is done in a fast manner, and all because of like less configurations, more focus on your business logic. So let's go to another slide. So we'll see some introduction to RESTful web services. So the whole idea of using Spring Boot is to develop APIs, and the APIs follow some architectural style. They follow some architectural style, and REST is one of them. REST is very popular as well. So if someone has like worked on a legacy application, there was another architectural style, and that was like SOAP style. We used to call SOA call. So when we used to work on those legacy applications, those SOA calls were also used a lot. But like those SOA calls were they had some XML payload, and you need to like have some kind of like middleware and all those kind of things. So maintaining a SOA architectural design project is quite tough, but it was the way earlier. Means let's say 15 years back or 20 years back, this SOA calls and SOAP architecture, this was getting used. Means because REST was not introduced, and REST web services were not introduced, so SOA architecture was getting used, and those were used in the applications. But when this RESTful web services came into picture, this made life a lot easier for everyone. And let's see what these REST web services are. REST web services are basically used for developing our APIs. Means it's an architectural design that helps you to develop APIs. And when we talk about APIs, we need to understand REST. Which API or like which architectural design should be used in creating our API contract. Means when we want to like achieve an business goal, we need to like decide what kind of API will this be. Will it be like fetching some data? Will it be like inserting some data into the database? Will it be like updation of some data in the existing table? Or what kind of operation it needs to be, it has to be done. So all those things, to achieve all these goals, REST comes into picture, and REST is one of the architectural designs, and it will help you to achieve these things. And we will need to understand what are the methods that REST provides you, and how you can basically achieve those goals. So let's go through this slide. So REST stands for representational state transfer. So this REST acronym basically stands for representational state transfer. So the main goal of RESTful web services is to make web services more effective. So its main goal is to make the web services more effective. RESTful web services try to define services using the different concepts that are already present in HTTP. REST is an architectural approach, not a protocol. Okay. So when we talk about HTTP, so HTTP is a kind of protocol. So you make APIs. So you use like HTTP status, HTTP request, HTTP response, and REST is a approach to basically create those request and responses. How you basically create that HTTP request, how you basically create that HTTP response. So that's an architectural approach. REST is an architectural design or approach, we can say. And HTTP, like HTTP basically stands for Hypertext Transfer Protocol, and HTTP is closely associated with the internet. So when I talk about HTTP, we can talk about different status codes. We can talk about different kind of requests that you need, and you different type of HTTP responses that you need to provide as an output. And those that's why HTTP is kind of a web protocol, and REST is basically an architectural approach or an architectural design, and it's not a protocol. Let's see further. REST does not define the standard message exchange format. We can build REST services with both XML and JSON. JSON is more popular format with REST. So REST does not limit you to use some data exchange format. So what I mean by data exchange format is when you develop an API, basically at that point of time you have to provide some kind of payload. Means when you develop an API, you will have to give some kind of payload, right? Some necessary information in for that particular API. Let's say you want to create some let's say you want to create a record of an employee in the database. You want to create a record of an employee in the database. So you will have to use some kind of like payload. You will need to have some kind of information for that employee. So let's say you will need information like employee ID, employee name, and employee designation, employee address, and yeah, this kind of information you would require. So this information you would be passing in a payload, and you need to have some format for that particular payload. You can pass this information in an XML format. You can pass this particular information in your JSON format. So when you are using XML for passing the data, you will have to use those Angular braces and some XML pattern of like creating your payload. And when you want to use JSON, so those who are not aware of JSON is basically JavaScript object notation, and in JSON basically you have like key value pairs. Means there would be a key and there would be a value associated with that, and this format is like very popular with REST. So this format has become very popular with REST. And while developing our Spring Boot applications, we would be using JSON format because this has like become the company-wide norm to use JSON now. Anyone who starts with an application today will go with the JSON format, and XML is still being used in some of the legacy applications, but people have like adopted to move with this JSON format. And the people who are still maintaining like legacy applications, they have also tried to move that particular component to the newer Spring based application component. Means what they are trying to do is they are trying to migrate that particular legacy application to the modern stack step by step. So everyone wants to move to REST, and with REST this JSON format is very popular. So we'll see when we start the development how we can like utilize this JSON format. So the key abstraction is a resource in REST. Okay. So when we like create some REST web services, let's say we want to create a new record, we want to like update a new record, we need to like delete a new record, or we need to like modify any existing record. So when we like create anything in the DB in REST, when we talk about the REST style, we say that we are creating a resource. And when we say like we want to delete some kind of object, or like delete some kind of record, we are basically deleting a resource. So resource is the abstraction that we will talk in REST. So whenever we are creating something, we are basically creating a resource. Whenever we are updating something, we are basically updating a resource. So in Spring or Spring Boot, when someone tells you that you need to create a resource, you need to understand that resource is like similar to some kind of like record that you are creating. So a resource can be like anything. So it can be accessed through a uniform resource identifier. So uniform resource identifier is basically like the URL. So whenever you create some kind of resource, you have to identify it with some kind of URLs. So there will be some kind of like URL for get, there will be some kind of URL for create, there will be some URL for updating. We'll see like how those URLs can be utilized. So the resource has representations like XML, HTML, and JSON. So you can like pass your payload in different representations that can be like XML, HTML, and JSON. But JSON is like very popular now, and we will be using JSON. So the current state captured by representational resource. When we request a resource, we provide the representation of the resource. So when you are trying to create your REST API, you have to like mention which kind of format you are using, which kind of like format you are using for representing your resource. So let's check another slide. So when you talk about REST, so REST provides you some HTTP methods. So there are some HTTP methods that will help you to develop your APIs. So these are some of the popular HTTP methods that are available with REST. So see this API, so see these methods which are available. So get method. So when I talk about get method, it basically helps to read a resource. Means you have some data in your database, means, and you want to basically that particular resource. So it can be done with the help of get mapping. Means when we start developing the APIs, you have to understand that for fetching some information, for reading some information that is already there in the database, you need to use get mapping or get HTTP method. So this get method will help you to read a resource. So when you develop your application, right, you will use some kind of annotations like @get or @get mapping. So that will help you to basically read that particular resource or fetch that particular data from your database or from service. Then there is like another HTTP method, and this method is basically your put method. So Put method basically updates an existing resource. So what I mean by that is you already have some record in the database or some record already created. So what you want to do is you want to make some modifications to that record. So when you want to modify some thing related to that particular record or resource, when we in REST terminology, we will talk about resource. We won't say the word record a lot. We would say that we would update the resource. So that resource is already existing and you want to make some modifications to that resource. So uh, when you have such requirements, let's say you want to make some modifications to an employee resource, means that employee resource information is there in your database. Let's say you want to, let's say the employee got some salary increment and you want to like modify that salary in the data layer. So what you would do is you would fetch that particular resource and then you would try to modify that resource. So for modifying that particular resource or updating that particular employee salary with the new salary, you can use this put HTTP method. So this put HTTP method is available with REST. Now let's see another HTTP method, that is post method. So post method basically helps you to create a new resource. Let's say some new employee has joined the firm. Let's say a new employee has joined some particular ABC company and you want to create that employee's resource in the company. Means that employee's information has to be fed into the company, right? Means his name and previous company details, his address, his personal address, his some family related address, those kind of information need to be fed into the company's database, right? So for achieving that kind of thing, you can use a post HTTP method. So this basically helps to create a new resource. So this is one of the important HTTP methods as well. So let's see another HTTP method. This is like delete. Delete is an HTTP method as well. So by name itself, it is like evident that we want to delete the resource. Let's say we have an requirement that we want to delete some particular employees employee details from the database or wherever you have maintained that employees details, you want to delete that particular details. So you can utilize this delete HTTP method for achieving that particular objective. So these are some popular HTTP methods like get, put, post, and delete. There are some other HTTP methods as well like patch, head, but those are not very commonly used. If required, we will see those as well when we develop the application. But these are the most popular HTTP methods like get, put, post, and delete. So let's see these examples of these REST methods, how the URLs would look like. How the URLs would basically look like when we want to create our REST methods. So let's say we are using, we want to create a user. So we have to basically use this post annotation. We have to basically use this post annotation and we can use this slash users. So this is basically kind of like URL pattern that you will be using to create a resource. So it's like for creating a resource, for creating a new user, what you can do, you can like use this URL patterns slash users, means along with this we'll be sending the payload as well in JSON that we will see while we are implementing those things. But for example, now what are the URL patterns we'll be using? Let's see those. So let's say we want to fetch the detail of a user. So what we can do, we can use this get annotation, or we can use this get HTTP method. And what would be the URL pattern? So let's say slash users. So slash users would be basically like getting all the users. And if you want to fetch detail of a particular user, what you can do, after users, what you can do is like put a slash and then provide the ID of the user. Let's say each of the employees have some employee ID. So what you can do, slash users slash ID. Let's say the ID of that person was 123. So what you can do, slash users slash 123. So that will help you to retrieve the detail of a user, and that detail will be in some kind of like JSON format, XML format, or HTML format. For our simplicity and popularity, we will use JSON format while we are implementing this. Now let's see another HTTP REST method example. Get slash users. So get, when we talk about get, again we understand that this is a kind of retrieval of information. And when we see like slash users, and in the third, I'm talking about the third example. So when I talk about like slash users, I'm talking about like retrieving the details of all the users, because I have not provided any particular ID. So in this case, I want to retrieve the details of all the employees of that particular organization or some particular department. So it retrieves the details of all the users. Now let's see another example. Delete slash users. So in the previous example, we saw how to fetch the details of all the users. So when we want to delete all the users, we can use the same URL pattern. It will be just a different HTTP method. Last time we have used get HTTP method. Now we want to use that delete HTTP method. So this delete HTTP method would delete all the users. Now let's say I have a requirement where I want to just delete the employee details of a particular employee. So what I can do, I can again use the delete HTTP method, and the URL pattern what I will do is slash users slash ID. This ID can be the employee ID. So with that particular employee ID, I can delete that particular user. Now let's say we have we want to create a user. Okay, there is some typo here, I think. Okay, okay. So if we want to create a user, now what we want to do is we want to create a particular user. We don't want to create lot of users, but we want to create a new employee detail for a just one employee. So what we would do, we can do some URL pattern like this, like slash users slash ID, and then we can pass the different payload in the payload. We will see how we create the payload once we start with the development and all, but the URL pattern can be like this, slash users slash ID. So this will basically create the details of an employee, of a single employee in the organization. Now, let's say we want to update the details of an existing employee or a user. So what we can do, we can use the put HTTP method. So put HTTP method can help us to update the details of an existing user. So we can use the URL pattern like slash users slash ID. See, whenever we want to do it for a single user, we need some kind of like identifier, right? That ID is that identifier. That ID is the identifier for that particular user. And if we want to like do it for like all users, we are not using that ID, right? See the difference in this REST methods. whenever we are like creating a resource or reading a resource or updating a resource or deleting a resource for a single user, we are also providing the ID in the URL. And when we want to like do it for all the users, we don't basically provide the ID. We just provide the like slash users or slash employees. We don't provide the ID. So that is the difference. So defining this REST APIs, right? Defining this REST HTTP contracts, these are like very important. Means you can like start with the development and like you can write the code, but when you just write this API contract, when you just write this API contract, right? The if any other person reads your code, they can like understand by just this URL patterns that what you're trying to achieve, they don't have to basically see your code base, the entire code base, to understand what your objective is. So define API contracts very clearly. Like if you want to like create a resource or fetch a resource, then you have to basically use that exact HTTP method, and the URL patterns should be very correct and precise, such that if anyone like reads your code, if anyone just takes a view of your API contracts, they would basically understand what your objective is. So it has to be that clear. So we went through this example of REST methods. Anyone has any questions in this REST methods? Okay, let's see through another slide. So when you're developing your application, right? So when you want to like create some kind of like you want to when you want to like perform some kind of operation. Let's say you are performing operation in a for an employee in a firm. So that, let's say you are creating an employee record or deleting a record or fetching the record or making some modifications to that particular employee detail. So at that particular time, there are chances that when you are trying to create a resource, you can like get a success, or you can like get the employee's detail is created in the database. Or sometimes what can happen, like you are trying to like create something, but you are getting some issue. Means there are some kind of like HTTP status codes that you can get while doing these operations. Or these HTTP status codes would basically give you an indication of how your API operation performed. Means if your API operation went well, if there was some issue with that, if there was some s- uh, issue with your server itself, if your application itself was not up. So there are some certain HTTP status codes that will basically help you determine how your API operation went. Means the API that you wanted to run, how that API performed will be determined by your HTTP status code. Let's say we take an example that I want to basically retrieve the detail of an employee with employee ID 123. So what I need to do in that case is basically I would use a get API operation, and what I can do, I can use some kind of like URL pattern like slash users slash 123. So what that means is when I use that get operation and I use the URL pattern like slash users slash 123, that means that the employee with ID 123, I want the detail of that particular employee, and that is why I'm using that get HTTP method as well. So just in case if that API gives me a proper response that I'm able to fetch that particular detail of that particular employee, then the HTTP status code would be 200. So 200 is basically success response, means we are able to retrieve the response of that particular employee detail. So this is a success response. So what our objective was, we have achieved. Now, now let's say we want to create a new employee resource in our uh, uh, s- in our database. So let's say a new person has joined our organization and we are creating a post request. So we saw that when we want to like create a new resource, we go for a post request, and we are creating a new employee resource in our database. So if that was successful, if creation of that particular resource was successful, then our HTTP status code would be 201. That means that a resource is created. So 200 means success, means this is kind of like a HTTP response, means once you provide an API request, and after that API request has performed the operation and it gave you some kind of response, this HTTP responses like 200 is kind of like indication that your operation was a successful one. And 201 is basically that you are able to create that particular resource, you are able to create that particular resource, and that was successful. So 201 will be that status code. Now what you are trying to do is you are trying to fetch the detail of a fetch the detail of an employee, and let's say you messed up with the URL, you have some typo in the URL, or the way the ID should be provided, you just messed up with the URL, or you messed up with some payload, means your way of providing the payload or your URL is not proper. There is some typo or there is some uh, some uh, something wrong with the payload that you have provided. So in that case, you will get a 400 status code, and 400 status code means bad request. So 400 status code would be bad request. Now let's see another status code, 401. So 401 is basically unauthorized. So let's say there would be certain applications, there would be certain applications, and those applications need some basic authentication in order to like access the APIs, and they might need some kind of username, they might need some kind of password. So for accessing the details in your API, you have to provide some authentication. And let's say you provided some wrong credentials, you provided some wrong username and password. So in that case, what you will get a 401 unauthorized. You will get a 401 unauthorized error. Let's see another status code. There is this 403 forbidden. So 403 is like your authentication. It is like similar to this 401, but there is some catch. 403 is like forbidden, means you are able to authenticate yourself, but you don't have special permission. You don't have permission to access that particular resource. Let's say in your API you are able to basically authenticate yourself, means you are a, means you are an authenticated user, you can access the application, but you do not have a permission to access that particular employee's data. Means let's say that employees data can be accessed only by the admins of that particular organization, and you are a user, you are able to authenticate but you are not an admin. So in that case you will get a 403 forbidden error. So this is the status code for that. Now let's say you are trying to you are trying to basically find a resource, find a resource, and that resource is not available in the DB itself. So in that case, what will happen? You'll get a 404 error. So 404 is another status code. Let's say if you want to fetch the details of an employee and that employee is not available, you can throw a 404 status code. Now let's say there is another status code, that is 500 server error. So let's say you have not handled some exception in your program very well, and you have not, your program went into some error state, and you have not handled that particular error state with proper exception handling and such things. So in that case, you will get a server error like 500 server error. Let's say let's see another status code, that is like 503. So 503 is basically like service unavailable. So what I mean by service unavailable is you are trying to hit the URL of a service and you are trying to fetch some information, but the service itself has gone down for some reason. That particular web service or that particular microservice has gone down. It is not healthy, means the status of that particular application is not healthy, it is not properly running. So in that case you will get a 503 service unavailable issue for that particular. So these are some of the status codes that you have to be very aware of whenever you are writing an API. So you have to provide some kind of like HTTP request, and after your API processes everything, it will provide you with an output, and that output is basically called your HTTP response. Both this request and response will be in JSON format, and with the response, with each API response, you will get some kind of status code, and these are some of the status codes that we currently discussed. Let's go to another slide. So what are the different advantages of RESTful web services? So RESTful web services are platform independent. So what I mean by platform independent is, so once you have like created your application and deployed it somewhere, these RESTful web services can be accessed from any platform. Be it like you are using Windows, you are using Mac OS, or you are using Linux based platform. So these RESTful web services are platform independent. They can be accessed by anywhere. You can, once you have like deployed your application, you are trying to access that particular resource, you are trying to like hit that particular endpoint or URL, it can be like accessed from any platform. So let's see the other point. It can be written in any programming language and can be executed on any platform. So this is again, this is about the platform independence thing, and it can be written in any programming language. So it's not that you can create RESTful web services with Java itself. There are like a lot of languages that will support. You can create RESTful web services with C++. You can create RESTful web services with JavaScript or any other programming language as well. So REST is, when I talk about this REST web services, it is not limited to just Java and Spring Boot. Any other programming language can also be used to create your REST web services. This is an architectural design, and this is in general. It is not limited to any programming language or any platform. So this is the advantage of RESTful web services. So let's see other point. It provides different data format like JSON, text, HTML, and XML. So these are the different formats you can utilize in order to create your request and in order to receive your response. So we'll see the when we go and develop this, we'll see how JSON can be utilized in preparing your request and response. So let's see other point. It is fast in comparison to SOAP because there is no strict specification like SOAP. So these SOAP protocols, right? These were the SOAP architectural style. There were like lot of limitations and lot of tedious jobs that we had to do in this SOAP architectural style, and that is why this was when REST was introduced, it gained lot of popularity because this is like quite fast in comparison to SOAP, because there are like less specifications in REST, and there is some flexibility while using RESTful web services. And these REST web services are also reusable, means we can create a REST web service and we can like reuse it again and again. So this is also one of the advantage of RESTful web services. Let's see this diagram. Let's see this diagram. This diagram is very important, and this diagram basically talks about Spring Boot architecture. So this is like very important, and let's focus on this diagram. This will talk about the entire architecture of Spring Boot uh, application. So what happens? Initially, you would type some kind of URL on the browser. Let's say you have typed some URL on the browser or on your Postman. There's a tool called Postman which we'll be using for accessing this for like accessing our APIs, using our APIs. There's a tool called Postman that we will be utilizing, and this Postman tool or on the browser you can like hit the URL. So that is like you are trying to create an HTTP request, means the client is basically trying to create an HTTP request. When I hit that particular URL with some payload, that means that I am passing an HTTP request. So how that HTTP request goes into our Spring Boot application, and how you basically get the response. So let's see that. Initial thing is you have typed in a URL with some payload, and that is basically your HTTP request. So a Spring Boot application has a controller layer. So controller is the front layer of your application, or it is kind of like, you can say, it's kind of like the front receiver of your any request. So and controller will be the layer which will provide the response also to the user. So this HTTP request is received in the controller layer, and what this does, this controller layer will call any method. It will call a method of the service layer. So your request comes from the client in the form of a HTTP request. HTTP request is basically like your URL with some kind of like a payload, and that data is received by the controller of a Spring Boot application, and from that controller there's a call. The controller calls your service layer, and in this service layer basically you write your entire business logic. So whatever business logic you need to write, you have to write in this service layer. And from this service layer you have written your entire business logic. So once you have written your business logic, you might want to talk to the database, right? You want to communicate to the database. Let's say our objective is to retrieve the employee details of a employee with employee ID 123 and working in the company. Let's say that company is named Meta, something like that. So what we do, we will use a get mapping, and we would use something like slash users slash ID, and in the payload in the JSON format we would name the company named Meta. Let's say we have passed this HTTP request to the controller. So now the controller will basically uh, uh, this controller will basically call the service layer, where the service layer there would be some kind of like method which will have some kind of like user ID and the company's name. So what we are trying to do, from the HTTP request, we have got some kind of like information, like we have got the user's ID, we have got the company's name. So we can pass this particular user ID and the company name to the service layer. Now this service layer is responsible for maintaining the entire business logic of the application. So we let's say this has some methods, it does some processing, and this service layer now wants to retrieve this information from the data layer or the database. So there is like this database, you can see in this diagram, right? There is this database. This service layer, this service layer will basically talk to the database. This will talk to the database and it will fetch some information from the database. Let's say those employee details were available in the database. So this service layer has communicated with the database and it has retrieved the information of that particular user. So it creates a model. So it basically, this service layer also creates a model, and this model is basically the data that will be basically sent back to the client. So, and while accessing this database, right, while the service layer is talking to this database, there are some operations that will be performed. Means a data layer is also called as the repository layer. Repository is also repository. When I talk about like repository, I talk about like the data layer or the database layer. So there are like some repositories like JPA repository. Means this JPA repository will be basically providing you with some utility methods for CRUD operations. So CRUD operations is basically, when I talk about CRUD, it's like CRUD is like it stands for create, read, update and delete. So create is basically your post operation, read is basically your get operation, update is basically your put operation, delete is your delete operation. So this JPA repository is basically helping us to perform some kind of like CRUD operations. And this service layer, see, I talked about dependency injection, right? So service layer will need the help of the database layer or the repository layer to fetch the information, because the repository layer will basically talk to the database directly, and this repository layer's object will be needed in the service layer. And this is like an example of dependency injection. Means, see, your controller would need the help of your service layer. Your service layer would need the help of your repository layer, and repository layer will basically talk to the database. So this way, controller is dependent on the service layer. So service layer service layer component has to be injected in the controller layer, and service layer needs the help of your repository layer. So repository layer component has to be injected in the service layer. So this is a classic example of dependency injection. We will see this when we develop our code, how these are like achieved in the code base. But see, the dependency, controller is dependent on service layer is dependent on the repository layer, and repository layer basically talks to your database. So repository layer gets the information from the database, it passes this information to the service layer, and the service layer further passes this information to the controller layer, and controller layer sends this information to the client. And this model is basically the data that is being driven between the service layer and the repository layer. So did you understand the entire architecture? Your client comes with some request. So the request is to get the details of an employee with some particular employee ID and working in some particular company. So in the payload you have passed the company name, and in the URL you have passed the user's employee ID. So this information went to the controller. Now the controller can pass the company name and the user's ID to the service layer. This service layer receives these two information, like the ID and the company information. So there might be some logic written in the service layer to fetch the information, and in that particular method it wants to communicate with the database. Now what it will do, it will call the repository layer. So the repository layer will have some kind of like method to directly interact with the database, where we have some kind of query. Last class we saw in the JDBC connectivity, right, where we had written some query to fetch some details from the database. So those queries, those SQL queries or those Oracle queries will be written in the repository layer. There will be some kind of queries written, and those queries will help you to fetch those data from the database. And once the repository layer basically gets that particular data, it creates that data in the form of a model, and it passes those it passes that particular response to the service layer, and then the service layer further passes that information to the controller layer, and the controller layer basically passes that information to the client from where that particular request was raised. So finally the client gets an HTTP response. So client has created one HTTP request, and the client will be further getting that HTTP response at the end. So this is the entire life cycle of the Spring Boot architecture, and in this way request and responses operate. Do you have any questions related to this Spring Boot architecture? Okay, let's move to the other slide. So we have already talked about this inversion of control and dependency injection. So let's see the differences. What is basically inversion of control and dependency injection? So Spring IOC container is the core of Spring framework. It creates the objects, configures and assembles their dependencies, manages their entire life cycle. So as we already talked about, inversion of control is a design principle which will help you to create the object, and it will help you to manage the object and their entire life cycle. And how in practicality this is achieved with the help of dependency injection. So let's see this second column. Spring dependency injection is a way to inject the dependency of a framework component by the following ways of Spring: constructor injection and setter injection. We'll further see what constructor injection and setter injection is. So there are like two ways of like injection. Those are like constructor injection and setter injection. So you understood, right? Means we want the help of a component in some other component, like in the previous diagram that we saw, like service layer needs the help of the repository layer. So repository layer is a component that needs to be injected in the service layer. So this is an example of a dependency injection, and this can be basically done in two ways, like constructor injection and setter injection. Now let's see the other point. Spring helps in creating objects, managing objects, configurations, etc. because of the IOC. Means this inversion of control design principle helps in creating these objects, managing these objects and configurations. And let's see the dependency injection section. Spring framework helps in the creation of loosely coupled applications because of dependency injections. So when we talk about the loosely coupled applications, we mean that these applications can independently exist independently exist and these applications can be broken down into small modules, and this can be deployed independently as well. So Spring Framework helps in the creation of loosely coupled applications because of dependency injection. Now let's see other point. Spring IOC is achieved through dependency injection. Yeah, we already talked about this, right? IOC is a design principle and dependency injection is the practical method to achieve this design principle. So let's see this section. Dependency injection is the method of providing the dependencies and inversion control is the result of dependency injection. This is again the same thing. Dependency injection is the method of providing the dependency. Means method of providing the dependency means it's like injecting one component in the other component. We also talked about that example, right, where the employee has an address. It was like address was one component which needs to be injected into the employee employee component. So that is like an example of dependency injection. Let's see the other point. IOC is a design principle where the control flow of the program is inverted. So IOC or inversion of control is a design principle where the control flow of the program is inverted. Means we are basically injecting the dependencies, right? Means let's say the controller requires a dependency with service and service requires the dependency with the repository layer, and we go ahead and try to create the repository layer, perform the operations, and then inject it into the service, and then service layer dependency is injected in the controller, and then the controller sends that HTTP response to the client. So this is achieved by the IOC or the inversion of control design principle. And dependency injection is one of the subtypes of the IOC principle. So IOC principle or inversion of control principle is basically having a lot of principles, and dependency injection is one of them. How we can inject the components in other component means one component is basically like dependent on the other component, and these components can be injected with the help of dependency injection. Let's see the other slide. So ways to achieve dependency injection. There is this constructor based dependency injection, and then there is this setter based dependency injection. So when we studied about this core Java, we uh, saw two things, right? You were able to create parameterized constructor, and you were also able to generate those getters and setters, right? So when we talk about like constructor based dependency injection, so what I mean by that is, let's take the example of this employee and address component. So let's say there's an employee and there are like some data members. Try to visualize this. Your employee is a class. Your employee is a class which has some data members like the employee ID, employee name, employee designation, and employee address. So these are the four data members. How you basically initialize these data members? You basically initialize these data members in your constructor, right? One way is that you initialize these data members in the constructor. This we have seen enough. And once you create the object of that particular class, you are basically passing values to that particular parameterized constructor, and you are initializing that. So now there is another class called as address, and this address has some data members like let's say that address has some kind of like street name, some state name, country name, some zip code. So you have created one address class, and both these classes can be called as components when we talk in Spring terminology. So when we talk about Spring framework, these classes can be considered as component. And you see, your employee has an address. So employee is basically dependent on this address component, right? So you want to basically inject this address component in your employee class. You want to basically inject this particular address component in your employee component. So now what you will do, you will initialize everything in your constructor, and when you inject that particular when you do that thing, right, this dot address equal to address in your constructor, that is basically injecting that particular dependency through constructor. Means you have injected address dependency in your employee class with the help of a constructor. So this is like a way of achieving constructor based dependency injection. Now let's say you have you are trying to like generate the setters. Once you get that option in your IDE, right, to generate the getters and setters. So once you generate the setters and you want to generate the setter for employee address. So what you are trying to do, in the setter method you will have something like one setter method like public void set address, and then that set address method will take your address object, right, it will take your address class reference, and in that method you will basically do something like this dot address equal to address. Means you are trying to use that setter method to inject that particular address in your employee class. So that is basically your setter based dependency injection. So there are like different scenarios where we basically go for constructor based dependency injection and we go for setter based dependency injection. But these are the most popular ways of achieving dependency injection. Means when I talk about dependency injection, you can like think of this example like the employee and the address example. So this is one classic example where the employee is dependent on the address component, and that component is being injected into the employee class. And the two ways are like it can be injected in a constructor or it can be injected in a setter method. So we'll keep this class until this topic itself, and we'll see further topics in the next class. And means there will be some theoretical concepts because we need to understand like how this entire thing works, and then we'll start with our practical demo. But you need to like understand these concepts as well. So uh, I'll give you the access to this particular slide as well. These slides that I've created, I've not given the access to anyone. By end of today or tomorrow, you'll get the access to these slides. So if you have any questions, you can ask them, or otherwise we'll conclude the session here. Okay, let's stop the session here.